SPH4U energy momentum 3.6 elastic and inelastic collisions. So there are three main types of collisions. So elastic collisions are where the total kinetic energy after the collision is equal to the total kinetic energy before it. So EK1 is equal to EK2 and P1 is equal to P2. An inelastic collision is a collision where the total kinetic energy is not the same as before, so EK1 it does not equal EK2, and P1 is still equal to P2. So completely inelastic collision is a maximum decrease in kinetic energy after the collision. So this is when the objects stick together. So it's like last lesson's question. So here EK1 less than EK2 and P1 is still equal to P2. So as you can see, all these types of collisions still follow the conservation of momentum. So here's an example of a question that deals with elastic collision. So a ball with a mass of 2.6 times 10 to the negative 2 kilograms and a velocity of 2.3 meters per second had an elastic collision with a ball of mass 2.0 times 10 to the negative 2 kilograms and a velocity of 0 meters per second. So what are the velocities of the ball after this collision? So we know that this is an elastic collision because it gives it in the question, so we know that kinetic energy is conserved. So let's call this equation 1. So 1/2 m1v1 squared plus 1/2 m2v2 squared is equal to 1/2 m1v1 prime squared plus 1/2 m2v2 prime squared. So there's 1/2 in all the terms, so we can cross that out. So that comes out to be m1v1 squared, and this second term with the m2v2 squared, that becomes 0 because v2 is equal to 0. So m1v1 squared is equal to m1v1 prime squared plus m2v2 prime squared. Be careful with the primes and your superscripts because you don't want to mix those two together. And for 2, we have for the equation 2, we have m1v1 plus m2v2 is equal to m1v1 prime plus m2 v2 prime, and this gets cancelled out because velocity is 0. So here is a quick diagram of what is happening in this collision. So before we have ball 1 with velocity 1 going to ball 2, velocity 2, that's equal to 0, right? So this is before. And after the collision, we have 1 going this way, so v1 prime, v2 prime. So that's what's happening. So the hits and then they both go off with their own velocities afterwards. So first, let's arrange equation 2 to find v1 prime. So m1 v1 minus m2 v2 prime all over m1, that is equal to v1 prime. So if we plug our numbers in, we would get v1 prime is equal to 2.3 minus 0.8 times v2 prime. So the m1 divided by m1, that's just 1, and the m2 divided by m1, that gives us the 0.8. So that's how we got this equation. So now we can sub 2 into 1. So m1v1 squared is equal to m1v1 2 prime plus m2v2 prime squared. So now we're trying to solve for v2 prime. So the m1 times v1 squared, that comes out to be 0.13225, so that is equal to 2.6 times 10 to the negative 2 times v1, so that is 2.3 minus 0.8 v2 prime. So, and all that is plus 2 times 0.0 times 10 to negative 2 v2 prime. Sorry for the mess here. So 0 is equal to negative 0.92 v2 prime plus 0.036 v2 prime, and this is squared. So 0 is equal to v2 times negative 0.92 plus 0.036 v2. So negative 0.92 plus 0.0362 prime is equal to 0. And if we rearrange to find for v2, you find that v2 prime is equal to 2.55 meters per second. Because this is quadratic, so we needed to factor it, and this is one of the factors. Our factor is 0, so this one makes more sense. So sorry about this. Now we sub v2 into 2. So we have v1 is equal to 2.3. v1 prime is equal to 2.3 minus 0.8 times 2.55. So v1 prime is equal to 2.3, so that's equal to 0.26 meters per second. So the final velocities of the balls after the collision are v1 prime is equal to 0.26 meters per second, and v2 prime is equal to 2.55 meters per second.